So today's session is basically on what I would call seeing the unseen, basically focusing on the intersect of applying AI and to power new business models, which are kind of disrupting many verticals. So it's a combination of disruptive business models, which is being powered by AI. And it's very, very interesting. A lot of it's been talking about how AI is disrupting, but lot of I would say depth has not been given into how the new business models are going to affect, what are the various types of business models and how it's going to really impact outcomes in each of these industries. Sorry, a little bit about the company where I work. Basically, sorry, there's a lot of animations. So we work in the industrial AI space. We focus on 3 industries: process chemicals, oil and gas, and heavy equipment. We take all that sensor data and impact process and equipment outcomes. We're working with companies like Honeywell, Henkel, and secondly, we won against, we're a young company, 70-member team. We won against big companies like Derick, Siemens, and Honeywell in their own backyard. And our commitment to the customer is we deliver impact in 90 days time frame. The industrial side typically takes about 12 months, 8 to 12 months to see impact. Our commitment is to deliver that in 90 days. So I'll just step back for a moment and share with you a few examples of things which I found extremely disruptive in the marketplace today. One was this university called Lambda, which is incubated by Y Combinator. And their commitment to the student is you need not pay a single dollar as student fee. Once you get placed, you pay 17% of your salary for 2 years. So the college is investing in the student instead of the student investing in the college. So they're actually flipping the model, actually. And they collect a lot of data to figure out which student. So what this means is you can be a student in a very impoverished country. You can still apply to Lambda universities, and if you overcome this thing, you will be completely funded. You will not pay anything. And once you get paid for the first 2 years, pay 17%. So very radically different business model where the college invests in you. The second is in our own backyard. Many of you would know this company called Atti Motors. How many of you heard of this? Atti Motors? No? In Bangalore. So these guys are making autonomous vehicles, self-driving vehicles to move products from point A to point B. One of the co-founders is just 14 years old, school-going student. Okay? And it's not in Koromangala, it's not in Indiranagar, the startup hub, it's in Malleshwaram. Okay? And these kind of disruptions are happening in our own backyard. The other is, actually this is a company which is solving the problem of early detection of breast cancer. 76,000 people die because it's not detected early on. Niramai, how many of you heard of Niramai? At least this one? Okay, yeah. So Niramai, so this is a company which is essentially trying to solve the problem of early detection of cancer so that these lives will be saved. And this is again using deep tech and completely having a massive human impact. The other thing it was very interesting to see is this hospital called Yashoda Hospital. Okay, and if you look at the bottom, you have a tag called robotic sciences. Hospital having robotic sciences as a department. So they focus on autonomous surgeries and they're getting a lot of equipment so that they can make sure that the surgeon is augmented with advanced precision tools so that the surgical outputs are maximized. Now, it is not happening in big cities alone. I just saw this thing, very interesting. There's a robot-themed restaurant launched in Coimbatore. I don't know how it will, I personally wouldn't want a robot to come on. But the larger point is people are thinking dramatically different even in small towns, small Class B towns. Then there was this shop called Water Sale in Cochin. How many of you have heard of it? Water Sale, right? Yeah. I mean, they're fairly game-changing in the sense that I think after Seattle's Amazon Go store, this would be the only store which is completely autonomous. You can go in, walk in, there's no cashier, walk out. And that's not in Bangalore, that's not in Mumbai, that's not in Gurgaon, it's Cochin. After Seattle, it's in Cochin. It's not even in the Bay Area. Dramatically different things are happening. And this is what we call as the age of accelerations, where the rate of change of technology is going at a dramatically high scale. And the human adaptability is kind of going on a linear scale. One is on an exponential scale, the other is on a linear scale. And that gap is very interesting. That gap between human adaptability and technology taking off is going to widen as time goes by. And the other thing which is fueling this change is very, very cultural in terms of how we respond to failure. The cost of making a mistake is almost zero. The best way to think about it is if you are into photography some 20 years back, I was a black and white photographer at that time. If I had to get the perfect black and white human expression, I would be very cautious of adjusting a lot of things, lighting, because every click costs money. But today I just click some 50 snaps and one of them would be good. The cost of making mistakes is literally zero. So that is one example. There are psychological safety nets for field experience. You can still go make a mistake and you still make sure that you're not dramatically impacted by it. There is risk capital which is allowing you to do that. And thirdly, the earlier mindset was when you make a mistake, it was called a defect. It was called a defect. Today, people are saying it's a learning, it's a pivot. Even the response to failure is dramatically changing. And I think this cultural mindset is this combination of technological changes along with that cultural mindset is going to fuel a lot of innovations. So I would like to look at it this way, that going forward, the traditional 9-to-5 job is kind of dead in the sense that you go to a company, do the same things over and over again. You either have to be an entrepreneur, in which case you take a lot of risk, or you have to be an entrepreneur. You have the safety net of the corporate. You have to do something different internally because the rate of change outside is very, very, very high. With these things, I'll just share with you some 3 real life, what you call use cases, which we did in the industrial sector to impact outcomes. The first is for a drilling contractor. Drilling for oil is almost similar to drilling for, it's like a borewell, glorified borewell. So as the drill bit goes into the earth's crust, it records a lot of parameters. What is the rate of penetration? What is the weight on bit? What is the pressure? What is the soil formation? All of this is recorded in sensors, and that data has always been traditionally collected. The problem they were trying to solve is it takes roughly about 18 to 21 days to drill for a hole. And there is something called invisible lost time, and every day it's roughly about $100,000. So the question they were trying to say is, can I look at this mountains of sensor data and squeeze out inefficiencies out of this? So we were able to save $40 million. I'll go through the arithmetic of it. But the crux of it is basically predicting 2 things. What is the rate of penetration at which you have to go, and what is the weight you have to put so that you will drill the hole in the given time window. And once you have enough data, you can learn about it and predict the optimal ROP and weight on bid so that the time taken to drill will be optimized. It's a very simple example of an efficiency you can do in the machine sector. The other thing we are doing is for a company called FMCT. FMCT is the largest manufacturer of subsea equipments in Houston. And they have a vision to go autonomous. Roughly about 70% of their operations, they want to make it autonomous, remove the human out of the loop by 2025. So we are part of the team. We are working on 7 different engagements, right, from flow meters to separators, where they are wrapping all these electromechanical devices with sensors. This will collect data, and there'll be algorithms which learn what happens and try to predict a future outcome. This is something that you're doing. The third example which I wanted to share is this is for a company called GTT. They are one of the largest transporters of liquid natural gas from point A to point B. When you transport LNG from point A to point B, one of the important criteria is it has to be transported at very low temperatures. So there are a lot of cryogenic sensors which detect minor fluctuations in temperature, and there are also leakage sensors and flow sensors. So there's a ton of sensors on that ship. And what we have done is created a product which sits on the edge. There's no cloud or anything of that sort. Sits on the ship. It's an edge intelligence product which collects all this data and does diagnosis of risk in real time and sends an alert out to the folks in this thing. So it's basically a doctor on the ship, if you will, making sure that this is actually a time bomb if the temperature fluctuates, because it could explode. So in terms of economics, it's very, very important. There's a lot of talk about AI, but I think it's very important to understand the economics behind that. So this is a case where talked about the invisible lost time. It unlocked roughly about $40 million. And if you look at it, number of days taken to drill each well is roughly about 21 days. Cost per day is about 100,000. So the invisible lost time is about 3 days. we are able to predict the right operational parameters so that we can bring it down to 2 days, which means you're taking off 2 days, which is $200,000 per well. So if a company has 200 wells, just roughly saving about $40 million. It's huge amount of money by removing so much micro inefficiencies in the drilling process. So the larger point is, if you look at most of these big, greasy electromechanical companies, very slow to change, very slow to getting digitized. Even if you take 1% of the data and squeeze out efficiency out of that, you'll unlock massive amount of dollars. Every fault mode is a company waiting to happen. So the best way to look at it is, if you ask how many customer analytics companies are there in the US, there'll be at least thousands of them. If you ask how many risk analytics companies are there, boutique shops whose only revenue stream is doing risk analytics, again, there are thousands. If you ask how many companies are there whose only job is to squeeze out machine data, unlock value, it'll be less than 15, 20. And there's a huge headroom to grow there. So with that, I'll just shift to the business models which can be powered by AI. So how many of you heard of the shop then ship model? Amazon's shop then ship model. So Amazon has collected so much data about consumer buying behavior that their prediction engine accuracy has dramatically gone up. So they have piloted a business model where they said, I will ship the product first, and it's up to the customer to pay for it. Ship then shop, because I know him inside out. Okay? And they piloted it model, and they have even applied for a patent to it. So it's basically because if there are two companies, one company can predict buying behavior much better than others, and the other cannot, this company will win the game, because anticipatory shipping is going to be a huge differentiator if it goes mainstream. So they're doing pilots, and unless until you're extremely sure, you can't ship it because your returns will be huge. It will be a logistics nightmare. But they really collected enough data about you to improve your prediction model that they can go to this, flip the model from shop then ship to ship then shop. The second one, so why is this business model very, very important? Because if you do not have the accuracy, there are two companies trying to do the ship and shop model, and if the accuracy of one is lower, you're going to have a logistics nightmare. It's very, very important to make sure that you have access to high value data which can improve the predictive accuracy. The second is G. G has again articulated a vision, and again they're doing pilots. They're saying instead of paying for the equipment, today if you had to buy a G jet engine, you upfront shell out $1 million. They're saying pay per thrust, which means I'll have sensors which will record everything about that equipment, including thrust, and I'll be able to use that sensor data to produce an invoice to you, and you pay for that. Okay? So you convert that sensor streams into an invoice, and you pay for that. Why is this business model important? Because from CapEx model, it's moving to without guarantees. You're shifting to an OpEx model with guarantees. You're guaranteeing an outcome. It's huge. It is very operationally aligned to the pricing model. So if I'm going to put if I'm going to use the equipment so many times, then only I pay for it. Last point is very important because it opens up new markets which are completely inaccessible. I'll tell you the example. We are talking to an Austrian hydro turbine manufacturer, and they said because of IoT and AI, they're thinking of a model where they traditionally used to sell only to European and US markets because they felt the turbines were so expensive for the APAC and African markets. So they said they have come out with a new version of the generator which is completely strapped with sensors and you know everything about it. They want to pilot it in Vietnam where there's a lot of water bodies, where they say, hey, the company need not pay for it upfront, only for every power of electricity which is generated or usage-based model, they're going to charge for it. And that's completely different because without this, they will not be able to enter into that geography itself. So a digitally strapped turbine is very important there. The third interesting thing is I found some interesting companies in Bangalore itself which were making small, very sensitive sensors. You could strap onto the stomach of the mother and it will start recording details about the fetus itself. So they essentially create a digital twin of the fetus on their platform, and they're able to record certain vital statistics. For example, They say undetected fetal disease distress causes about 3 lakh deaths every year. That's a huge amount of thing. And they're creating this low-cost device which will, at a minimum, record heartbeat, and it will record kicks. So if a baby has been kicking 2 weeks in a row, third week it has not kicked, it will automatically send an SMS alert to the gynecologist. So very interesting, very small things done at low cost. And they want to be the largest collector of fetus healthcare data in the world. That's their aspiration. They want to collect that. So why is this business model important? There are so many new opportunities which get unlocked when you have to monitor something in real time. For example, there's one company, I forgot the name of the company, which just monitors sugar levels, diabetic levels in patients in real time. Very important, especially when your parents are here, some of their children are abroad. They pay every month a certain amount of money to make sure that the parents' diabetic condition is a real thing. They're not at all price sensitive about that. They'll pay a premium for that. There's so many yet to be born businesses, and of course, many of you can ride this wave. And this is another interesting model. This is something which we are talking to some of our customers. It's a vision we have. It's basically what we call as Uberification of industrial signals. So if you look at it one side, supply side, you have a lot of equipments. Just by connecting an AI platform and sensors, you give them voice. Suddenly a motor can say, hey, I'm going down, I'm feeling unhealthy, and that signal comes and sits in your platform. I'm low on lube oil. Whatever that cry for help is from that machine, we give a voice to that cry. And that signal comes and sits in the platform. And on the left side, traditionally to service that, if you have to go and fill up lubricant oil, somebody from inside the company does it. Now, if you open it up to a private industrial marketplace, you can have a market-based, two-sided market platform where people in the ecosystem can go and, basically doctors for the equipment can go and service that request. And this is, again, a game-changing business model because slowly you start expanding the breadth and depth of signals you listen to. From a machine point of view, the number of machines which can be connected to this platform could be huge. Why is this business model important? Because it actually squeezes out a lot of inefficiencies in the system today. There's a lot of inefficiencies because only a few people can go and, it's like having a monopoly. Lube oil, only 3 people can do and service it. So it's kind of, think of it as the Practo for the machines. Suddenly you can find a lot of people who will get bubbled up who can service these inefficiencies. Fifth model is very, very interesting where this is basically, for example, Progressive, an insurance company. They give a small device which needs to be attached to your car, and that device starts recording how many times you braked, how many times you speeded. Your driving behavior is recorded in real time, and that information can be encapsulated into a single score, and that score can go to your insurance provider. And essentially, he has data which says, here is the zip code, here is the average driving score habit, so that I'll give you a pricing model based on that. So instead of giving a very highly risky pricing model, he's able to look at actual behavior and tune the pricing related to that. Now, why is this important? Because sharing behavior data to get lower price model is even being expanded to healthcare. So there are some pilots being done where you share some of your anonymized, not anonymized, personal wearable data, how many times you walked, how many times you exercised. Your healthcare provider will give you a nice pricing model for sharing that behavior data because your risk is dramatically decreased because you're doing yoga or walking regularly. So it completely disrupts the insurance pricing model. The other example which I want to share is from Ford. Ford has been a very close company which has a lot of data regarding the performance of its equipment on the field. They never really opened it out to outsiders. This is radically different in the sense that they formed a consortium called OpenXC, where they let a limited number of private startups to get access to the data. It's just read-only access to the data, engine health and crankshaft data and all of that stuff, so that they can create the small apps to diagnose the health of that equipment. So what this does is it's kind of, think of it like an Apple-like business model for the industrial sector. So you can have hundreds of startups which are coming up with diagnostic, prognostic apps, which can be sold on the Ford platform. The startup makes money, and as well as Ford makes money. And this is a new business model which is being even done in the oil and gas industry. Why is this important? You can crowdsource the best. It is not necessary that the best talent should lie within the walls of your company. What this does is you get access to outside brain power to power the health of your own business. Secondly, most of these companies are looking for digital revenue stream. They're tracking how much year-on-year growth am I getting from digital revenue streams, whether it is digital services you provide as entertainment inside a Ford car, or whether it is diagnostic services, because these services are going to get them very, very predictable revenue streams, and which are recurrent also. Very focused on that. And if you look at overall what is happening, every large company is getting unbundled. This is an example of Honeywell, where if you look at their website, there are a lot of services they offer, right from thermostats to rebates and wired chimes and security systems. And every offering, there is a new startup which is targeting that offering with a very different value proposition. For example, Nest was one company which just changed two things. They made sure that the thermostats were have very boring interfaces. They just changed the interface so that it was very Apple-ish. People felt like holding it in their hands. The second thing they did is made sure that thermostat starts learning about your behavior and starts tuning your temperatures automatically. There are only two tweaks they made. Dramatically altered the interaction experience for the customer, and they embedded a small bit of software which learns your behavior and proactively tunes the temperature when you're coming in and going out. With that, they got phenomenal market share. And similarly, you'll see many young startups focusing on a very narrow, deep value proposition to disrupt the incumbent-led space. So with that, I'll just focus. I'm not going to the deep math or anything else. From a practical application point of view, what can you expect to see in the near future? The first big thing is human emotion detection. There was this company called Emotion.com. I think it got bought out by some large company. I forgot which one it was. I did a very interesting experiment. They had this thing where they will record your live video. And from that video, they will decide what kind of emotions are showing on your face. Very accurate. I only thought my wife and my mother could read what is going inside my head. But there's a piece of software which is recording me and climbing into my head and saying, this is how you're feeling. Very eerie it was, but it's possible today. So if you look at this, what it's showing you is it's trying to read the expression on the face of that kid. And it has a high probability on surprise is the first expression it has given a big probability to. The second is happiness. So it's a combination of happiness and surprise which has been detected on that. So emotion detector algorithms are going to go mainstream. This is another example of that. So it looks at the face, not only detects the face, it also detects the emotional state of that person. So what this means is, suddenly we're going to have an explosion of emotion data which can reside on a cloud, and people who have access to it can create new business models. Emotion data is now available for analysis. So one of the use cases for this, they were saying, is the task of counseling. So people go to a counselor, and let's say you have a 1 hour session, you have to pay them $500. Almost 70 to 80% of the time, the doctor first time is trying to understand your emotional state. So 70% of their time is trying to access your emotional state through a set of questions. What they feel is something like this, a software like this, can quickly augment that information and help you with the emotional score of the person by asking the right questions. Again, the way you design ads could change, because you're going to have, instead of interviews, you're going to have emotional readers to detect whether an ad is resonant or not, right? So a lot of these things. The other interesting use case was, I think somebody was talking at an autonomous car conference where they said, the car will decide whether to give handover of the steering wheel to the human, because if that person is exhibiting rage, I will not give it back to you, okay? So very interesting use cases where the algorithm is going to start reading you deeper. The second trend, what I thought was, is basically algorithms. Today, if you go to see cameras and a lot of things can record human faces. If human face comes into the frame, there are face detectors. Now, it is moved from face detection to activity detection. It can also say what kind of activity that person is doing. A young boy is holding a baseball bat, a cat is sitting on a couch with a remote control, all of that stuff. So a lot of companies focusing on this, 20BN, DeepMind, IBM Watson. So what they're doing is they're exposing the algorithm to a lot of activity information with tags so that you'll be able to read the activity. So why is this important? From a security perspective, you have video cameras. That video camera, in addition to saying a simple alert, it can tell you what is the activity that person is doing. Person is running away. That verb can be transmitted to the security people. In an industrial side, it can start, the camera can start essentially saying a motor has begun to rotate. I don't see any people doing any activity. So this camera has become a sensor and can start forming English sentences to the command center folks. Very game changing, I would say. The third trend is what I would call democratization of AI. AI is seen as a very high priest kind of thing where only people with deep math and a crown on the head can do it. So what companies are starting to do is they are truly trying to what I would call API-fy the algorithm. So all the complexity goes inside today, and you just have an API call and you can get the job done. So there are basically, for example, if you want to design an app for food analysis, there are apple detectors, orange detectors, all readily available off the shelf. You need not know a lot of deep learning or anything. You just have to make sure that you can stitch it all together and get the job done. So Amazon is doing a lot of work in exposing this ready-made, pre-packaged detectors. Microsoft is doing a lot of work. Of course, Google is doing a lot of this work. Why is this trend very important? Lot of pre-trained models. So you'll start seeing marketplaces of ready-made, pre-learned APIs so that you don't need to have complex data science kind of folks. You can have a normal hacker come and stitch it together and can really transform business models. The next trend I wanted to focus up on is what I call verticalization of AI. So you have today a lot of very generic companies which are focused on sentiment analysis, customer scoring. But what we are finding is more of them are becoming very business problem backward AI companies. I'm going to solve frac pump prediction. I'm going to solve legal fraud analysis, that kind of very, very narrow and deep solutions powered by what we call vertical AI solutions. Why is this trend important? Because if any of you are starting to build an AI company, make sure that there is a reasonable amount of domain with your AI. It's a nice combination. It's a nice cocktail. If you combine 70% domain with 30% AI, it's a nice business model. The next trend I want to focus on is what I call edge intelligence. So there is central intelligence. So somebody in data is poured to the cloud and command center people do that, and the other is edge. So for example, over-the-air updates. If you look at Tesla car, one of the things they did is they just upgraded a set of software and shipped it to all the cars. What it did was increase the autonomous driving capability of that car. Well, it is game-changing in the sense that normally if you want a car update, you have to go to the dealer and it changes a lot of stuff. In this case, the guy did not have to go to the dealer. It was there in his house. The car automatically got upgraded to the next version of it because a lot of things was digitized. So increasingly, you'll see any electromechanical, any chair, table, anything, you see will have a certain component of digital component to it, and you can upgrade the product by upgrading the software on it remotely. And so the over-the-air updates is going to become a very, very important feature which can dramatically change the consumer experience of the product itself. So that I just come to the thing. So we quickly covered AI trends, AI business models, and AI and ROI kind of thing. But increasingly, I think all of you will encounter AI in some project or some shape or form. So how do you get started on this journey? Whether you want to start a company or whether you're going to apply it in a corporate, how do you get started on this? So there are 5 important what I call conversation starter questions. The first is what is the problem you're trying to solve? What's broken in the current user journey that needs to be fixed? Very, very important, very sharp answer you need for that question. Second thing is, how can you reframe that business problem into a prediction problem? For example, if you look at autonomous driving, they reframed the driving problem into saying, what is the steering wheel, what is the brake pressure I should apply in order to drive automatically. So you have to convert a business problem from that domain into the data and prediction model. So how do you map that problem into the prediction world? Third question you need to answer is, what is the dollar value which will be unlocked if I solve this problem? It's a very simple thing, but most people miss this out because they get so excited by the technology that they forget, are you solving a high value problem or not? Fourth is, what is the access to high value data sets you have? Algorithms are a commodity, and it will become a commodity. Algorithm is not the layer on which you're going to have competitive differentiation. It is going to be access to data, which is going to really differentiate. So people are going to wall garden their data itself so that that becomes a source of competitive advantage. And finally, what would success look like? So these are the 5 simple questions one needs to ask. And in terms of org structure, so people have said, what kind of org structure you should have? Should you have a chief AI scientist? Should you have a data engineer? You should have a sales head. In our company, we kind of simplified it into 3 things. One is you should always ask yourself, do you have a hacker who will solve the problem? Whether he has math experience or not, he'll do jugaad and solve that problem. Okay? He's a problem solver. His focus is on solving the problem. You don't tag him with data scientists or anything like that. Second is hustler. You need a hustler. And we don't call him a sales guy or a marketing guy because we have seen a lot of sales guys who could not get us in front of a target customer we have. You need a hustler who can get the job done and make sure somebody opens the door, you're in front of him, and you get access to that person to tell your story. Third thing is storyteller, who will tell the story of your company or your proposition in a very, very compelling way, so which is the best version of your aspiration. So normally we look for 2 out of 3 skills. If you have all the 3 skills, you should start your own company, I would say. Thank you.